Hi everybody and welcome. Today we're going to be talking about scale factor. So your goal after watching this video should be able to conceptually understand and also calculate problems that involve scale factor. So I think the best example of this was actually my dogs. Now if Winnie was an exact copy of Stella, so if he was a little pit mix instead of a little Chihuahua mix, and they looked exactly the same, but they were different sizes, that's a really good example of scale factor. So Winnie's about 6 pounds, Stella's about 60 pounds, so they are in a good 10-to-1 ratio. So the scale factor of Winnie's that we could fit inside of a Stella, basically, or how many times bigger Winnie would have to be able to do a one-on-one matchup with Stella, would be about 10-to-1. So that's an example of a scale factor, is you take something smaller and you basically replicate it or multiply it in a constant quantity until it reaches the exact proportional size of the bigger thing. So again, Winnie is the smaller thing, Stella's the bigger thing, and if we have a whole bunch of Winnies, they'd fit into a single Stella. So that's the idea here. And also, cute little Halloween costumes for them too, if you missed that the other day. All right, so let's start off by defining it here. So scale factor, again, is defined as a number that multiplies a quantity in a constant proportion. So the most common example you might see is shapes, again, that look about the same. One smaller, one is relatively, again, the same shape, but just a little bit bigger, a little bit blown up. That'll show us a scale factor. And again, to get from shape 1 to shape 2, we have to multiply each part of that shape by exactly the same thing. So that's a scale factor. So if it takes a 10-to-1 ratio like Winnie and Stella, the scale factor is 10-to-1. So again, a lot of times it's in that unit rate form with like a 10-to-1 or 2-to-1 or something to 1 type quantity. And that's a good sign that we're looking at scale factor. Pretty commonly used in things like maps, if we're trying to blow up pictures to larger sizes than they are, things like that. Comes up really frequently and a really good skill to know. So here's an example of one problem that you'll likely see, and what's going to happen is generally they're going to say, okay, these shapes are proportional, one's just a little bit smaller or larger, and we need to find a missing side. So a couple things to note before we start is that these are proportionally lined up. So our small side is on top, our long side's on the side. So sometimes you have to like flip them or rotate them, but in this case, it's already lined up for us. So the second thing is we also want to label what we have here. So if we're going to call this like 10 is our length, and 15 is our length, and our unknown is our width, and 24 again here is our width, we have to make sure we're setting lengths equal to lengths and widths equal to widths. So when I was talking about that Empire State Building example before, a lot of times what you'll see is you'll have your large Empire State Building in the background, and then sometimes they might take that little figurine model and put it on its side. So before you start comparing edges, we need to make sure that it is rotated correctly. Otherwise, we're going to have a really long building that's really short, whereas the Empire State Building is a skinny building that's really tall. So when we're setting these things equal to each other in that proportional rate, again, really important that lengths are with lengths and widths are with widths are with widths. Otherwise, we're going to have a different shape than what we started with, and that is not the goal. We're trying to make them exactly the same. Again, in order to do that, make sure the same matches up with the same. So on the left side, 10 is our length, over x is our width. On the right side, 15 is our length, over 24 as our width. And this just turns into a problem where we can do our cross multiplication. And again, we showed some really good mastery of that on our quiz last week, so we're in good shape for this, but again, step by step. So 15 times w equals 240, and again, 240 is from 10 times 24. And then we can just go through, finish this question up, and get that answer for the missing side. So 240 divided by 15, and we'll get that answer, and we can move on from there. So punch that into the calculator. Again, big numbers, even if you have an idea, always good to be 100% certain. We have a width of 16. So let's take a look here. Width equals 16. Is that reasonable? So 15 on this shape here, a little bit less than 24. Here 10, a little bit less than 16. Looks to be in a reasonably similar proportion, so it looks like we calculated our scale factor correctly. A second type of question to get us started. Again, we have a photo, and the photo is obviously smaller than the real image here, so our monster that we are trying to see how big it would be based off of this photo, length and width-wise. And again, we want to set that up. So maybe we'll call like this our base, and this is our height. And again, we can set that up in our proportion. So 18 is our height, 5 is our base, and they're telling us that it's 8 feet tall. So now we need to find how wide is it, or x, for our base value. So again, another proportion that we can set up and solve for. And again, with that same idea of having that base and height lined up directly across from each other. So any questions on these, definitely reach out and let us know. But again, excited for some good real world